Hello guys, it's your favorite teacher once again, Godson, and this is Wits Lounge, Learning Made Easy. For those of you that are just joining us and you've never seen this video before, remember to subscribe and like our videos, and then put on the notifications to get more videos on understanding different aspects of the science subject. Thank you very much. Okay, today we're going to be learning something very popular to most of us, and that's redox reaction. You should have heard of this before. Once you go secondary school, you should have heard of this before. Redox reaction. So the question is, what is redox reaction? Most of the times, we tend to see redox reaction as a word. No, it's not a word. It's actually an acronym of two words: reduction and oxidation. So, two words put together, we have redox. Now, there is no actual definition for the word redox. However, I would like to say that whenever you talk about redox reaction is basically defined as two simultaneously occurring reactions which have opposite effects. The reactions occur at the same time, but their effects are opposite. What do I mean by that? For instance, if you say reduction is one thing, oxidation has to be the other, the exact opposite. This is to say that if I say that reduction is someone tall, oxidation is someone short. If I say that reduction is someone fat, oxidation is someone slim. You know, you can look at me and say that's, anyway, that's. Now let's come back. Now my point is this: if reduction is something, oxidation is the exact opposite. Now, earlier times, there have been so many things used to describe oxidation and reduction: oxygen, hydrogen, electronegative substances, electropositive substances. However, the most important definition of reduction and oxidation is with respect to electron transfers and oxidation number. Electron transfers and oxidation number. As we know, electrons are negatively charged particles which are found in the orbit of every atom. Every atom consists of electrons, and they are found in the orbit. And then, when you talk about the oxidation number, you are simply trying to describe the charge possessed by a particular atom. Now, with that said, let's come back. I said there are two major things used to describe redox reaction. If you want to define the redox process, there are two major things that are used to define the redox process. Number one is electron transfer, and number two is oxidation number. Now, before we get to the definition, I just want to put up an illustration that may help us understand this more. Now, I would like you to imagine the atom as a human and the electron as an offering given by a human. For those that are Christians, those that are Muslims, whatever religion you are in, there is one constant factor, and that constant factor is that whenever you give, your blessing tends to increase. That's the general factor. You know, luck, favor, whatever you call it. The point is this: every giver usually has an increase in blessing. Now, look at this. Human would give money or offering or whatever, and then we have blessing. Now, with respect to the atoms, what you have is atom. The atom is analogous or synonymous with the human in this illustration. What does the atom give? It doesn't give money, it gives electrons. And then what happens, or what is the blessing of an atom? Oxidation number. Okay, now with that said, my illustration: whenever a human loses or gives money, the blessing of the human increases. That same way, if an atom gives electrons, the oxidation number increases. So have this in mind, that if you want to have an increase in oxidation number, you have to have a loss of electron. If you're going to have a decrease in oxidation number, that means you have to gain electron. Come on, look at it. You go to church, you're dancing, and then you put your offering in the offering box. What happens? Eventually, our preachers tell us that the blessings of that person increases. But imagine, for instance, you see a beggar on the streets begging, and you walk to the beggar. Instead of putting money, you collect from the beggar's home. Guess what happens to you? Your destiny can be changed because of that. Anyway, if you believe in that, it could work. But my point is this: that if you give, blessings increase. That's for the humans. That means atoms, when they lose electrons, their oxidation numbers increases. It becomes the other way around. When they gain, the oxidation number decreases. Okay, so let's continue. Now, with that established, let's now come to defining them individually based on electron transfer and oxidation number. So, what do we have here? Whenever you are talking about oxidation and reduction based on electron transfer, oxidation is the loss of electrons. Loss of electrons. While reduction, remember what we said, that whatever oxidation is, reduction is the exact opposite. So if we say that oxidation is the loss of electrons, it implies that reduction is, yes, you got it, the gain of electrons. So you could look at the term reduction and be like, reduction, gain. More like a paradox. But then just have this in mind, that if you have oxidation is the loss, that means reduction is the gain. Try to put it in your head. And one of the ways to put it in your head is repeating it over and over and over. Oxidation is the loss, reduction is the gain. Once you do this, repetition births retention. Now let's come back to the drawing board. Now have this in mind. We mentioned earlier on the human money blessing analogy. It implies that if we had to describe oxidation with respect to oxidation number, if oxidation is the loss of electron, that is, electrons are given away, the implication of the statement is this, that as you are giving away electrons, what happens to the oxidation number? It increases. Remember what we said, that when you have an increase in oxidation number, it comes about by loss or giving away electrons. So when you have oxidation as a loss of electrons, it means that with respect to, let's put this over here. Sorry about that. Let's get this cleaned up quickly. Okay, so with respect to oxidation number, that's my abbreviation for that ON. With respect to oxidation number, you have that oxidation is the increase in oxidation number, which makes reduction the decrease. Okay, so in this case, you see that reduction, decrease, it actually coincides here. But when you're talking about the electron, it's the other way around. So, but I told you guys, one of the things that might help you is if you they give offering, that's for those who don't understand broken. As you they give offering, something they happen, blessing they increase. That means as you they lose electron, oxidation number they do waiting increase. The other way around, reduction is the gain. As you are gaining or collecting that money, you are collecting that offering, you are taking from that beggar, something is happening to your blessing is decreasing, and that's reduction. So just have this in mind for those that are watching this video, that whenever you describe oxidation is defined majorly by on basis of two things, and that's electron transfer and oxidation number. With respect to electron transfer, oxidation is the loss of electrons. That is with respect to electron transfer, while reduction has to be the opposite, which is the gain of electrons. On the other hand, with respect to oxidation number, oxidation is defined as the increase in oxidation number. You know, oxidation number actually coincides or something like that. So oxidation is the increase in oxidation number, while reduction is the decrease in oxidation number. In the next video, we are going to be describing these things in detail so that we'll tend to understand them. Thank you very much for watching. Remember, this is Wits Lounge, learning made easy. Thank you.